Yo, yo, Algebrainiacs! Welcome to the Johnson Kendrell Video Hour.
But it's not an hour.
Yeah, we're gonna log in some time though today. Just be ready for that. All right, here we go. Oh,
What is this? Says, go to the next page. I couldn't figure out.
oh yeah, I remember now.
Mrs. Kendro made these slides.
I'm not as tech savvy as Miss Johnson. That's what happens with the older generation. We have a lot to learn. Okay, but we are gonna give you guys a lot to learn here too. Go. All right, we're gonna talk about exponential and logarithmic equations. So we're gonna be solving these. Here are a couple steps. First, we need to convert into the log form.
What are the two forms again? Tell me.
Exponential.
Okay, and what does that look like?
That's just got a variable for our exponent.
And then the other one is log form. What does that look like?
That
Log
b to the y equals x.
Okay.
All right, so we got those written down. So now, and then we're going to use our change of base formula. That's a nice little shortcut to help us out here. All right, so solve 2 to the 3x equals 172. So we've got this 2 to the 3x, x like our b and x up above, and 172 is our y. All right, so we'll do this log part. So log to the base 2, and then y is 172 equals 3x.
So you're just switching between the two forms.
Right, we haven't solved anything yet. Now, change of base. Remember, you take the base of 2 and write log 2, or sorry, 172. And then you put that over log of 2.
And the point of doing that is so we get base 10 so we can use calculator.
Right. When you see no little base number there, it's in base 10.
Okay. So how do you type that in?
So we're just going to say log 172 divided by log of 2.
Okay, and let me get my calculator. When we do that, we get something like this. Should I round that?
No, 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 no. Don't round till the very end. So
okay.
You keep that whole decimal in your calculator.
And then we want to get x alone.
Divide by 3.
Divide by 3 on both sides. This is the time when we want to round. And we should get something like this.
Right on. So don't round to the last step.
I was kind of wondering, can you check your answers with these?
Sure. Put that 24754 back in for x. Now, because we rounded, it might be off by a tiny bit.
But it should be pretty close.
Yeah, like 171.9 or something.
I also wanted to ask, I don't think the textbook teaches it this way. So what does the textbook do?
Right, yeah. Let's show another way to do this.
I'm just going to erase over here just so I've got some room.
All right.
Okay, so what would the book do?
The book says to take the log of each side. So we start out by saying log 2, yep, and then log of 172.
And
then move that out front.
Using power property.
Yep. And then divide to get the 3x alone.
Isn't that what we did anyway?
Yep, we kind of got the same thing. So you can choose whatever method you want. We're probably going to do the first method in class, but if you like this method of taking the log of each side, then moving the exponent down front, more power to you. Go for it.
I just like our method because we did so much practice converting between the two forms.
Right.
I think we'll
so we're already
prepared
used to that.
for that. Okay.
Here's another one. So we're going to change
form. Yep. So right now our b is a 7, our 5x is the x, and then the y is the 3,000. So to convert to log form, we would have log base 7 of 3,000 equals 5x. Using change of base formula, we can do log, which is base 10 of 3,000, divided by log of 7 equals 5x. We'll do this log part in our calculator. Make sure you close the parentheses when you do that. Yep. Let's see, we get 4.1144 equals 5x. So what's the last step we need to do?
Divided by 5.
Divided by 5.
And we get approximately 8. Oops, back it up. Here we go. 0.8229. And we're always going to round that last one to the 4th decimal place.
10,000th.
Yep. And I didn't write that divide by 5.
You did, but you undid it when you did your little redo. Okay, so those were exponential equations, and we solved them by converting to log form. So now we're going to solve a log equation. What form do you think we'll convert to?
Exponential?
Yeah.
All right.
All right, let's do, well, let's talk about the hints. It says use log properties. So those were...
log props, is that like props made out of logs?
Maybe.
Maybe we have to go to the drama department to get log props.
There was product property, quotient property, power property.
All right.
Isolate the log. This is key. We're going to show you how that comes into play in a little bit. Convert it to exponential form. When you do that, you will be able to just use exponents to solve for your x, and then you can check your answers. You don't necessarily have to, but just like we told you, you could plug your answers back in.
All right, let's try it.
Let's do it. All right, so use log props to write as one log. It is one log.
So we don't have to do that log prop stuff.
Right. Next thing says isolate the log. Now those parentheses are around the 7 and the minus 2x. That means that that logarithm applies to that whole expression.
Right. Now I know because there's no number there that's really base 10.
Good job. So that's like our b.
Yep, so I could say b to
the x power equals the y, which is the parentheses stuff.
Yep.
10 to the negative 1, that is 1/10. Or you could do a decimal, doesn't really matter. And then your steps will be subtract 7 and then divide by negative 2. Running out of room there.
So I get negative 6 and 9/10 equals negative 2x. Now at this point, put them into decimals probably?
Yeah, that would be fine. So we just put it to a decimal there. So next step would be divide by negative 2. And, let me see, positive 3, and then half of 9 would be 4/5, so 4/5.
Nice. Good mental math skills.
Thank you very much. Now, it said we could check. So what you would do, you are able to check this because this is base 10. So I would kind of, in the calculator, do negative 2 times 3.45, then do 7 minus that, then do log of that, and you should get negative 1.
Good. And that should be pretty exact, right?
Yes.
Because we didn't do much rounding.
Yeah, there wasn't any rounding for this one, so that's good. Okay. It says use log properties to write it as a single logarithm. I only see the word logarithm once, so I think we're good.
Yeah, and there's no parentheses, so this, we gotta isolate the log for sure.
So what do you mean by that?
Means the part that has the log with it is kind of stuck to it like glue, so we gotta get rid of everything else. That +1 goes to the other side.
Okay.
Just like a regular equation.
So log.
So log 3x is kind of like your x that you usually have to get alone. So base 10, so 10 to the 4th.
Okay, so I'm doing 10 to the 4th equals
3x.
That's 1 with 4 zeros.
Yeah,
right?
10,000 equals 3x.
Divide by 3. Alright, so I'm dividing by 3. That's going to be lots of 3's. 4 3's and then 4
4 more 3's.
That's x, and that's rounded.
All right.
So you could check it. You got to use the right order of operations, though. You'd have to do 3 times that, then take the log, then add 1,
And it should be 5. Good.
All right, let's do some more.
These are kind of fun
Yeah.
once you get used to how to set them up.
All right, log props.
Okay, we got a minus in there. That means quotient.
Okay, so that, what about this guy?
That's an exponent we got to put out with the x.
All right, so writing as a single logarithm, we would have x squared, but then we have to divide by.
The minus turns into the divide line. You could think of it that way.
Yep. So that's a single logarithm, base 10. So
10 to the 2 equals.
Okay, and then can I square root right now?
No, we got to isolate. Anything you want to get to solve for, you have to isolate.
I better square this first.
100 times 3.
Times 3, so 300.
300 equals x squared. Now you can square root. You're going to scare both sides? No. So we're not scaring both sides. We're actually square rooting both sides. So
Do we need plus or minus?
no, you're not really ever taking a log of a negative. So we're never going to use the negative
All right.
in the problem.
So square root of 300.
You got to break that up.
Yeah. Okay. So
100 times 3, would that be? That's got to be the biggest.
10 root 3.
Right.
Would we accept the decimal, you think?
Yeah.
It's not as
Just
good.
follow the directions. If it says exact, use the radical. If it says round, then round.
Sounds simple enough. You mean we should read directions?
Read them and follow them. Okay, I see a plus sign. I see powers out front. We got a few things to change here. So take the 3, put it with the x, and make it 1 log, and then x3. Okay, now we have a plus sign. That means multiplication. So write the word log once, and then it's x3 times 2, so 2x cubed.
Right.
Okay, now you got the power of 10. 10 to the 5th equals 2x cubed. Wow, a lot of zeros. Una más. Good. Bueno.
That's a comma, not a.
You know, in Europe it would be a dot.
I know, that gets
They're
confusing.
backwards.
Our exchange students could tell you about that probably.
Yeah, so they do it backwards. They would put a dot there and a comma as a decimal point.
So what now?
Divide by 2. Good. And then cube root that.
Ooh,
1,000, I know, is 10 times 10 times 10.
Okay, so
we could start with that. Cube root of 1,000, and then cube root of 50.
So that's 10 cube root 50.
Any cube roots in 50?
Let me think. That's 5 times 10. 10. Nope.
No, it either have to be a 27 or an 8, and neither of those work. All right, so that is it for the exacto mundo answer.
So let's summarize. So when we had log equations, we converted to
Exponents.
And when we had exponential equations, we converted to
Logs. And we had to use some of the log props.
log props.
All right.
Hey.
Ta-ta for now.
See you guys.